Stackr is trying to do is build execution engines on top of DAs and L1s. So the entire construct is of a L2 rollup, which developers can define. They can define their own state machines. They can define how the transactions are constructed, how the state moves, and all of those things. So this is inspired by the fact that right now what we have is very boring. Like all the rollups that come up are just the same thing, just modified and just have a few tweaks here and there. Most of them are EVM based now. Like recently we have been seeing a rise in alt VMs. So we have Move VM, we have Solana VM, and all of those things. However, it is still that it's not up to the developers to modify. Like you still get what you get. I mean, if you want to do something else, you don't really have a choice other than just like using the same VM and just doing some tweaks here and there. What if you want to have a state machine that does something very different than what is allowed with other stuff? And also, other than that, there is like a lot of bloat that comes with all these state machines. So let's say you're building an application which requires to do X, and the state machine allows you to do like a lot more than that. Obviously, it is good for general purpose construct, but in that case, what happens is you lose the efficiency of the system. So in case you want to do payments, like why can't you just focus on payments, just have like a state machine that can take in tokens, does like some accounting, does some account management, all those things, and that's all what it needs to be there. So as Prabal and Nick were mentioning, rollups are a lot of things, like let's not get into that, but overall what happens is that you need to somehow offload transaction load on the base layer, move it to some off-chain entity that does some computation, and finally once that computation is done, you take that data and you store it back on L1 so that it is there for there as a guarantee that okay, this computation actually happened, and these are the changes that happened from that state. So as just to put together everything, so okay, let me get like a better marker. Yeah. So rollups are like a compute engine on top of like the parent chain. So if we think that this, let's call it the L1, and then on top of that on the off-chain entity, these are all L2s or rollups, and this is where Stackr lies in. So Stackr is a 3-tiered architecture. So even the L2 is split into 2 parts, wherein we have the app layer on top, and we have a verification layer underneath it, and whatever happens in this particular layer then just gets rolled up into blocks and submitted on L1. So we came up with a concept which we like to call micro-rollups, and these are nothing but independent state machines which the developer defines, and you can do like a lot of things with it. You can just define how the state transition function is defined, how blocks gets created, what the transaction format is, and all of those things. So as everyone keeps mentioning, like the state transition function, which is sigma of t+1, which is state at t+1, is nothing but the state at t plus you take all the transactions and you apply a transition function on top of that. And this is essentially what everything what we are playing around with. So we give you tools so that you can define your own state transition function and essentially create a state machine. So this is equation for a state machine. And what we do is we take the state machine, wrap it in a blockchain, and then that wrapped blockchain acts as a rollup. So it is inspired somewhat from the Substrate SDK as well, that allows you to build blockchains, but we wanted to take it like one step further, wherein it's like even easier to build and much more intuitive on how those things are abstracted away from. So if we talk about rollups, rollups are like obviously like they seem like a complicated entity, but in general they have a state machine at its core, and this state machine is actually independent of the rollup itself. So we have a state machine which gets wrapped around by an execution engine, which gets wrapped around by a sequencer or something which orders the transactions and gives it to the executor. So here is here's the sequencer. And then finally, this sequencer, all of this construct gets wrapped around with like some network APIs and all of the other things that allows you to interact with these. So it could be like networking or P2P or whatever. And this entire Venn diagram is a rollup. And for most of the parts, the thing that changes across rollup constructions is the middle part, which is the state machine. The executor can remain the same, the sequencer can remain the same, the networking API and all of those things could remain the same. But what differentiates one rollup from the other is basically the state machine. And what we essentially do is we give you tools so that you can write this part wherein, okay, I created a block, it gets submitted on L1, and the validity of those blocks are already proven by the verification layer, and then that means basically my transactions life cycle is complete. So this is like the end-to-end flow. Now coming on to messaging, like we have one micro-rollup here and other micro-rollup here, and we keep talking about the analogy between micro-rollups and microservices. So the neat part of microservices is that they can just focus on one small logic and take help of other microservices to achieve like a bigger task. So what can happen is this Vulkan layer itself has another layer on top of it, which acts as a messaging layer. And this helps in interop. So once a micro-rollup submits a block of transaction, after Vulkan verifies it, it can just like for example, it submits a block, the Vulkan layer verifies it, and then it can send the state routes to the other micro-rollup to perform like the cross composability, so something around that. So I think, yeah, this probably answers your question. And yeah, that basically completes the life cycle of the micro-rollup. One more interesting thing that we are doing with it is, not sure if I can move a lot, we give certain we give granularity in terms of confirmation levels. So instead of transactions being valid and invalid or basically just accepted and reverted, we give multiple guarantees that, okay, the transaction can go through multiple stages. So over here, once a request is received to the MRU, it gives a confirmation. We are calling it C level. So it gives a C0 that it is acknowledged. Since it's a centralized environment, we can't really say that, okay, if I send a transaction to a micro-rollup, it may or may not respect that, and it can just like not accept that in a block. So we created a new confirmation level, which is C0. That means the MRU acknowledges that transaction. Once the transaction is applied to the state machine, at that level we give a C1 confirmation, which is that, okay, this was applied to the state machine and the state at this app layer was moved ahead. Then that reaches the Vulkan layer verifies all of those things and gives you another confirmation level, which is C2, that, okay, the blocks were valid and a proof has been created for that block. And once the proof reaches L1 and DA and L1 both proves that the data is available and settled, it gives you another confirmation, which is C3. So as you go from C0 to C3, obviously the time increases, time goes up, but at the same time the security guarantee also increases. We personally feel that this is a very good UX for users, because they can immediately work on C1 and move the users to the next state without actually waiting for Vulkan to give a C2 confirmation that, okay, the state was valid, it got applied to the state machine, I got a C1 confirmation. So for different use cases, I can work on different C levels. For lighter use cases like games and stuff wherein I require like millisecond latencies, I can just say that, okay, I'm happy with C1. It's okay if the C2 comes in later, but eventually it's gonna come. So I can just say that, okay, if I receive C1, I'm gonna move the user to the next state. But for more complicated use cases like DeFi and all, ones where we require more additional security checks, we can wait for C2 and say that, okay, if I received a C2, then I can move the user to the next state. So this C0 happens instantly. It's like about 0 seconds. C1 happens in a matter of milliseconds. Then C2 happens in a matter of maybe like a few minutes to some hours. And then the C3 settlement time could be arbitrary. It could be like a few hours to a few days as basically you define the settlement logic over here. So yeah, that's probably around it. That's the entirety of the architecture, how it looks like. And yeah, I think just to wrap it up, we recently announced a DevNet for this construction, and we are onboarding developers to start building on this construction, and we feel that a lot of use cases could be built around it. Technically this can support any kind of use case, but we are more excited about seeing a few priority ones like attestations or maybe reputation systems, some DeFi related use cases, and especially games. So in case someone wants to build those things, we are happy to chat, and yeah, that's pretty much it.